There will be a word problem on the test tomorrow. A word problem. It will either be like this, or I will give you total time, or I will give you equal time. So if I give you total time is like 3 hours, what would you do? You take this time plus this time equals 3, correct? If I give total time. If I say it takes the same amount of time, what would you do with them? Take this time and set them equal, correct? If I tell you there's a difference in time, like this one, I said Tom takes 0.2 hours less. I don't know why I crossed off less time. So Tom's time is less than Ted's. Do you agree? Tom's is less than Ted's. So if I take Ted's and I subtract off Tom's, what's it going to equal? 0.2, right? So if you take the longer time minus the shorter time, it equals the difference. So the longer time is the slower person, which is the one that's going slower, which is x. This one's x plus 35. So it's going to be 36 over x minus the shorter time, which is 36 over x plus 35. And what's going to be left over? 0.2. I won't make you convert to hours tomorrow. I will just give you an hours question. There's a good chance I'll give you like a total time question or an equal time question over a difference, but I wanted you to be able to see the difference. Okay? So if I give you a total time, you just take the two time boxes, add them up, set it equal to the total, correct? If I give you equal time, you just set the two time boxes equal. The time boxes are always the two that you're filling in with the formula, correct? And when in doubt, where do you put the variables? On the bottom, because it's a rational unit, right? The variables are going to be in the bottom. Yeah?
Will this be numerical response or conditional?
Written response, because I want to be able to give part marks. If I do it as numeric, it's either 0 or 1. Yeah. So it'll be up to 2. Even just setting up the box correctly will get you 25. Setting up the equation correctly will get you 1. Solving correctly will get you 2. All right. So just getting to this equation here, this is 1 out of 2 marks. Okay? Then we just have to solve it. So we need to first, it's a solving question. So our first steps when solving are GCF difference of squares or factor the denominators if I have to. There's nothing to do. Second step, bless you, is to make common denominators. So this one is x. I'm going to multiply by x plus 35. This one has an x plus 35. I'm going to multiply by x. Why didn't I just multiply this one by 35? Why didn't I just multiply the first one by 35? Yeah, it'd be 35x. So when one's a monomial denominator and one's a binomial denominator, you multiply them by each other. Yeah?
Wait, what is it?
So up here it asked, determine the time of Tom. So once we get x, we can plug it into here and get Tom's time. Tom time. So once you get your x, you can plug it back into your chart wherever you need to get your answer from, right? So if they ask for Ted's speed, then I would just give the answer to x. If they ask for Tom's speed, I take whatever x is and add 35. If they ask for Ted's time, I take 36 divided by x. If they ask for Tom's time, I take 36 and divide it by, in brackets, x, whatever x is plus 35. So you just go back to the chart to fill in your x. All right. This one just has a 1, so I'm going to multiply it by x and x plus 35. When it's just an x and an x plus 35, I just make the x join the 0.2 first, and then I'm going to distribute it through. So I'm going to get 36x plus 35 times 36 is 1,260 minus 36x all over x plus 35. These two actually cancel off, which is really nice. Then on this one, I'm going to get 0.2x times x is 0.2x squared And then 0.2 times 35, I believe, is 7x. Yeah. So once my denominators are the same, what can I do? Get rid of them after I do NPVs. So I have x can't equal 0 or negative 35, which makes total sense because x is speed. So neither of those would actually work anyway. So now we're going to get 1,260 equals 0.2x squared plus 7x. And what do I have to do when I have a square? No.
Oh,
Move everything to one side, set equal to 0, and then factor a quadratic formula, correct? Every time you have an x squared. You're going to end all of 30-1 questions, almost all of them, by factoring a quadratic formula half the time. Because whenever you have a squared, you need to immediately, your head just needs to go, move to one side, set equal to 0. Move to one side, set equal to 0. Move to one side. When it's just an x, you can solve for it. You can move the number over, and you can divide by what's beside the x, right? When it's just an x, it's nice and easy. When it's a squared, you actually have to move everything to one side, set equal to 0. So we're going to get 0 equals 0.2x squared plus 7x minus 1,260. And then this is my A, this is my B, this is my C. Quadratic formula. So I get x equals negative 7 plus or minus the square root of 7 squared minus 4 times 0.2 times negative 1,260 all over 2 times 0.2. So x equals negative 7 plus or minus some sort of number. $1,057. Now we split it up. Because it's a word problem, one of these is going to make sense and one of them won't. X, if you look in the boxes, x is in speed, correct? We see it's in the speed box. So does a negative speed make sense? No. So if one of them is a negative speed, that one's going to be extraneous because it's not going to make sense. So we are going to go negative 7 minus the square root of 1,057 divided by 0.4. And then negative 7 plus the square root of 1,057 divided by 0.4. So negative 7 minus the square root of 1,057 divided by 0.4 is negative 98.78 kilometers per hour. What does that say? Does that make sense? No. And we'll check the next one. Negative 7. Oops. 63.6 or 78 kilometers per hour. Does that make sense? That one makes sense. Now let's answer every question that I could possibly ask you. So if I asked you for Ted's speed, I would go up to my chart and I would look in the chart and I would look for Ted and speed. Ted and speed is x. We just found Ted's speed, did we not? So Ted's speed, I know I didn't ask for this, but we're going to go through and answer all the questions I could possibly ask. So I could ask for Ted's speed, done. I could ask for Tom's speed. So I go up to my chart, and Tom's speed is x plus 35. So it's going to be x, which is 63.78 kilometers per hour, plus 35 kilometers per hour. So Tom's speed is 98.78 kilometers per hour in his motorhome. Then I can ask for times, right? Because the times also have x's. We agree? So what's Ted's time? So I go up here. Ted's time, I take 36 and I divide it by whatever x is. Okay. So I'm going to go 36 and I'm going to divide it by x, which is 63.78. And I get 0.56 what? Hours. And then if I want Tom's time, I go back up to my chart. And Tom's time is 36 over x plus 35. So it's 36 over x plus 35. 0.36 hours. Okay, I'm going to give you another one to try. Because why? You have one on your test tomorrow. Okay, so here, I'm going to read this first part because it's information, but it's excess. So, the Northern Manitoba Trappers Festival held in the Pas originated in 1916. I think it's the past or whatever. A championship dog race has always been a significant part of the festivities. In the early days, the race was non-stop from the Pas. What is PAS? I know it's in BC. No, it's in BC, to Flin Flon. Flin Flon's in Manitoba. And back. Anyways, this is what is information. This is the information that matters. In one particular race, the total distance was 140 miles. Conditions were excellent on the way to Flin Flon. It's a place. Flin Flon. I'm pretty sure Flin Flon's in Manitoba.
Doesn't matter the condition where. It's in Canada. Yeah.
Don't know. It's in the book. Just right.
It's Flin Flon. They do it different.
However, bad weather caused the winner's average speed to decrease by 6 miles per hour on the return trip. The total time for the trip was 8.5 hours. What was the winning dog's dog teams average speed on the way to Flim Flon. All right. So let's decipher what we have here. So we have 2 Flim Flon. And then we can do back. So distance, what total was 140 miles. So this is going to be 70, and we can write our units up here, miles, to help us out. So is this one going to be 70? Now, it says the speed was decreased by 6 on the return trip. So if I take the speed and I decrease it by 6, it's a return trip. So this would be x. And then this would be miles per hour. And then I gave you total time, which is down here, is 8.5 hours. Now I told you there will be 2 boxes that are empty every single time, and you will use the formula to find them every single time. If you haven't noticed, for all of these that we've done so far, it has been time.
I wonder why.
Shocking, right? Time causes the x to be on the bottom, which causes it to be a rational equation, and therefore in this unit. So time is distance divided by speed. If you're questioning whether the x should be on the bottom, it needs to be, or this is not a rational and it shouldn't be in this unit. Okay? Total, whenever you have total time, total means you add them. So I take the time to Flim Flon and I add the time back, and it should give me 8.5. So this here, this table and the equation is already half the marks. Okay? Then we need to make common denominators. So we're going to multiply this one by x minus 6. This one by x. This one by x and x minus 6. So I'm going to get 70x minus 420 plus 70x all over x minus 6 equals 8.5x squared minus, what's 8.5 times 6? 8.5 times 6 is not 14. I'm like, it has to be at least 8 times 6. 51.6 x over x minus 6. Now that I have full denominators, I say x can't equal 0 or 6. So if it did, those would be out. All right.
What do you times it by?
Mine was, I got
I thought it was-
51 plus.
Yeah, because you times
If you look here, I have 8.6 times 6 in my calculator. There be the problem. So it's just 51. Oh my goodness. So we can drop our denominators off because they equal, correct? So if denominator equals denominator, numerator equals numerator. So 70x and 70x is 140x minus 420 equals 8.5x squared minus 51x. The moment I have an x squared, I need to move everything to it, correct? So I'm going to subtract 140x and add 420. I'm going to subtract 140x and I'm going to add 420. So I get 0 equals 8.5x squared minus 191x plus 420. Okay, did everyone get those numbers? Yes. Now, we have to go to our quadratic formula. So, we're going to get A, B, C, x equals minus 191, so 191 plus square root of 191, negative 191 squared, minus 4 times A times C, all over 2 times A, So 191, oops, one, shh. So I got 22,201 under the square root. Guys, quiet please. And over 17. And so I get 191 plus square root of that. And when I add them, I get 20. And when I subtract it, 191 minus the square root of 22201, I get 2.47, da, 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 da. Now, people are like, why doesn't this one work? Well, if I go up to my table and I put x is 2.4, it works for this one, correct? But what if I go 2.4 minus 6? I now have a speed of negative something. Is that possible? No. So, this one is an inappropriate answer. So we put a line through it, we put extraneous. And I can't subtract 6 from it. So my only answer is 20 miles per hour. And that's actually the answer. Because the question that's asked, the question they asked is, what was the winning dog team's average speed on the way to Flin Flon? So speed to Flin Flon is just x. So when I get x, it is the answer. So 20 miles per hour. So I'm going to give you this. Okay, guys, try the questions, please. All right. So here we're going to have to add our root 3 first. Shh. And so we'll get 2 sine theta equals root 3. And then we'll divide by 2. And sine theta equals root 3 over 2. Sine is which? X or Y? Sine is Y. So I'm looking for where all the y's are positive root 3 over 2. So it's going to be in quadrant 1 and 2 because that's where y's are positive, correct? Now where are the y's root 3 over 2? Here and here. So at 60 and 120. So you're going to say theta equals 60 degrees, comma 120 degrees. Now sine negative 270 is lovely, but it's not on my unit circle. So I have to do what to it? Add 360. So when I add 360 to negative 720, I actually get the answer of sine 90, which is on my unit circle. Sine is y. So what is y at 90? Go to 90 and give me y. 1. Good. Cos negative 120 is lovely, but it's too small. I'm going to add 360 to it. So it's the same answer as cos 240. Cos is x. So I go to x at 240, and you give me the answer of negative what? Negative 1 over 2. Then we have sine 480. We subtract 360. We get sine 120. So I go to 120 and give me the y, which is okay, what if I ask for tan? Say I ask for tan 120. Tan is sine over cos. Okay? Tan is y over x because it's tan your x box. Y is sine. So tan I can rewrite as sine 120 divided by cos of 120. What is sine at 120? root 3 over 2, divided by cosec 120. What's cosec 120? Negative a half. If you're people who just keep looking for other people to look for the answers, that's a scary test to be writing. Because they're not giving you the answers, and I don't know if you know how to find them. So you scare me when you're those people. Negative root 3. Remember, all 60-degree tan reference angles are root 3s, and all 30s are root 3 over 3s, and all 45s are nice because they're 1s or negative 1s, right? Because you do root 2 over 2 divided by root 2 over 2, stuff like that. So I want you guys to try this one out. Tan of 210. 3 over 3. And tan is in the quadrant where it's going to be positive. So it's going to be in positive root 3 over 3. But if you don't know that, that doesn't matter. You can go sine of 210 divided by cos of 210. Sine of 210 is a half, negative half, sorry, divided by cos 210, which is root 3 over 2. Then I have to flip it. So I get negative a half times 2 over root 3, which is negative 1 over root 3. And then what do I have to do? Rationalize, rationalize, rationalize. Oh, sorry, this can be negative, negative, positive.
Wait.
What?
Negative 1 times.
I canceled the 2's.
Oh.
You could put 2 over 2 and then just cancel them off. That still works too. All 30-degree tans, I promise you, will be root 3 over 3's. It just depends on what quadrant they're in. So, if I go cast, because you're always going to do a half divided by root 3 over 2. This one, if I ask for tan of 30, is tan positive or negative here? Is tan positive or negative in quadrant 1? Positive. Everything's positive in quadrant 1, right? So this is going to be root 3 over 3. What about this one? Is tan positive or negative? So tan 150. Is tan positive or negative in this quadrant? It's negative because the only thing positive here is sine, correct? So it's going to be negative root 3 over 3. What about this one? Tan 210. I know it's root 3 over 3. Is it positive or negative though? Positive, because what's positive here? Tan. And then what about this one? Tan 330. It's going to be root 3 over 3, but is it positive or negative? Is tan positive at C or negative? I really hope you're saying negative, because that's a C and not a T.
Yeah.
Also, when you divide y's and x's in that quadrant, you're going to get negatives, because one's positive, one's negative. Right? So that's of 30s. Tans of 60s. Let's do those. Tans at 60. If I go here, tan 60 is going to be root 3. Is it positive or negative? All are positive, so it's positive. And if I do the 60-degree reference angle here, that's tan 120. Is it positive or negative? There's an S. Is tan positive or negative? Negative, because the only thing that's positive is sine. That's why the S is there. So it's going to be negative root 3. This one is 240. And it's root 3. But is it positive or negative? Positive, because the only thing positive here is T, which is tan. And then this one's 300. So this root 3. But only c is positive here, and c stands for cos. So this is negative. What's the only other reference angle? 45s, correct? And what do 45s result in? 1s or negative 1s. Because you're doing root 2 over 2 divided by root 2 over 2, which is 1. Or root 2 over 2 divided by negative root 2 over 2, which is negative 1. And then your other tans are at the 90s and the 180s. So if this coordinate here is 1, 0, I'm going to do 0 divided by 1, which is 0. That's okay, correct? So tan of 0 degrees is 0. But tan of 90 degrees, what's my coordinate here? It's 0 and 1. So it's going to be sine, which is 1, divided by 0. And what happens when I divide by 0? Undefined. So tan at 0 and 180 is actually 0. But tan at 90 and 270 is actually undefined. Because you're going to divide by that 0. This is differences with your tans. Okay, we're going to flip to the reciprocal graphs I handed out to you. These ones. We're going to talk about reciprocals again. Reciprocals just mean you take the graph of what you have and you do 1 over f of x. F of x is just y, correct? So for every reciprocal, we're going to remember what we do. So for ever given a graph, our mapping is going to be xy becomes x comma 1 over y. So all my x's stay the same, and all my y's get put under 1. That's it. Correct? What else do we know? The invariant points. Where are the invariant points on a reciprocal? What y values if you divide under 1 get you the same answer? When y equals 1 and negative 1. Because if I do 1 divided by 1, it's still 1. And if I do 1 divided by negative 1, it's still negative 1. So invariant means they don't change. Correct? So it's at y equals 1 and negative 1. Where do I get my vertical asymptote at? Is when y equals 0. Because if I do 1 over 0, what do I get? Undefined, right? So this is the x-intercept. And for these, I always have a horizontal asymptote. At y equals 0 as well, at the equation y equals 0. This is when y's are equal to 0. So, I immediately do this. When I get to this graph, the first things I'm going to do is I'm going to put my horizontal asymptote on the x-axis. And you're like, I wonder if it changes. It doesn't. Look at me. Go. Every single time. My horizontal asymptote is the x-axis. Yeah.
I should write x equals 0. Like for that.
The x-axis is what equation? Not x equals 0.
Or
Y equals 0.
you have to write that.
Yeah. If I ask you for the horizontal asymptote, you have to write it. If not, you can just draw a dashed line. It doesn't matter. Where do my vertical asymptotes happen at? X-intercept. Oh, crud. So I go to my x-intercept and I make myself a vertical asymptote. Here's my x-intercept, correct? So I have a vertical asymptote at x equals negative 2. And I'm using short form because it's my notes. And we could say horizontal asymptote at y equals 0 because the x-axis is the equation y equals 0. So this one I have a horizontal asymptote at y equals 0. And here's my x-intercept. So I have a vertical asymptote at x equals 2.5. So wherever my x-intercepts are, I get a vertical asymptote because it would be 1 divided by 0. Like this coordinate is at negative 2, 0. It's going to become negative 2 and 1 over 0. And am I allowed to do 1 over 0? No, so that's why I'm getting an asymptote there. This coordinate would be at 2.5, comma 0. It's now going to be at 2.5, comma 1 over 0, which is an asymptote. So your x-intercept become asymptotes because it'd be 1 over 0, right? Going down to these ones, I'm just going to end up with what? 2 vertical asymptotes, right? Because I have 2 x-intercepts. So this one is going to get me a vertical asymptote. Oops. And this one. And this one. This one's on the y-axis. And the equation of the y-axis is x equals 0. So I can put my horizontal asymptote, correct? I can put my vertical asymptotes wherever the x-intercepts are. Then I can put my invariant points on every single one next. Where are the invariant points going to happen at? When y equals 1, it's going to stay the same, and y equals negative 1, it's going to stay the same. We'll see why. So if I go here, I'll use green. So when y equals negative 1, this one looks like it's at, that's not negative 1, that's negative 2. Negative 1's about here. So it's going to stay the same because I'm going to keep the x and it's going to be 1 divided by negative 1. And this 1 is going to stay the same. So I bold it. Then here, this would be at 2, 1. It's going to become 2 and 1 over 1, which is still 2, 1. So it stays the same. That's negative 3. What am I doing? Here's it. So this one's at like 2.5 and negative 1. It's now going to be at 2.5 and 1 over negative 1, which is still negative 1. So they stay the same. So you do your horizontal asymptotes, your vertical asymptotes, and then your invariant points. So down here, I'm going to have invariant points when y equals 1 and when y equals negative 1. Here I'm going to have invariant points when y equals negative 1 and 1. How do we get more points? Take all the original points off the graph, keep the x, and put the y under 1, right? So if we go back here, let's just finish this graph off. So I have negative 4 and negative 4. We agree? That's coordinate on here. We can even pick another one. I'm going to go start here. Negative 6 and negative 8. What's negative 6 and negative 8 going to become? Negative 6 and 1 over negative 8, which is a really tiny decimal, correct? So I'm going to go to negative 6 and negative 1/8. Boom, there it is. And it's negative 0.2. Then I go to my next coordinate, negative 4 and negative 4. Negative 4, comma 1 over negative 4. So it's negative 4 and negative 0.25. So it's here. And then here's my asymptote. So remember, this runs along here. These connect, and then they run along here. They don't cross over. Then I pick points on the other side. So here I have 0, 4. 0, 4 is going to become 0, comma 1 over 4. So 0 and 0.25. Then I have 2 and 8. 2 and 8 is going to become 2 and 1 over 8. So 2 and 0.2. And then these run along here with an arrow, and this runs up here. Pretend that's a straight line. That's a terrible line. That's not any better. It runs along there. It should be running straight with the blue line, but I did a terrible job. You guys try this one. Pull points off and get new points.